Great. So everyone who's joining us, we're just getting started with introduction to science topics. And my name is Leila Nordmann. I work here at the Fairbanks Museum and along with Bobby Farlice-Rubio, who will be teaching this segment. So I will go ahead and hand it over to him. So I'm going to stop sharing my screen.
Hello, everyone. I'm Bobby Farlice-Rubio, for those of you watching online. And yes, this is our Introduction to Science Topics class, where we're continuing an exploration of the constellations that are visible in tonight's sky and going wherever the questions may lead after that. So if you're not already familiar with it, please get Stellarium on your computer. I'm going to show you folks what this software looks like. It's free, and you can download it at stellarium.org. And then after this talk is done, everything we talk about, you'll be able to do yourself at home. And right now I've loaded up Stellarium, and it looks like what it would look like outside if it was maybe summertime without any snow on the ground. And I'm going to zoom up to see where the sun and the moon are. But in this program, I'm going to fast forward just like we can in a planetarium to show what's going to happen tonight in the sky. Because actually, you're going to want to see this when the sun goes down if our clouds clear. In addition to having the moon in the sky, you'll also have planet Venus. The moon will be a thin little crescent. Let me see if I can zoom in. It'll be so thin that you may not notice it. It'll be one of those fingernail moons, as some people like to call them. But Venus will be actually easier to see. Even though it's a tiny dot, it's going to be so bright, you're going to notice it before any other lights of the stars come out. Venus, of course, being a planet and being the closest planet to the Earth, it's often the brightest thing in the sky besides the moon. So let's go back to a more natural view, and we'll go through the twilight. As the moon becomes visible, in Stellarium, the moon looks like a little dot now. You have to zoom in on it to get it to be, look the way it does. But let's get the bigger picture and look at the whole sky. So last week, we focused on what was in the south. I'm not going to cover the constellations again, but you can see lit up near Venus what we were talking about as the winter circle or the Mariner circle. Stars like Aldebaran, Capella, those are the Gemini twins, Pollux and Castor. And then there's Procyon and Sirius and Rigel. All of those stars make a circular pattern that you can easily learn, and it gives you a lot of constellations to focus on when you're out in the winter sky. But today we're going to talk about what's in the other directions in the northern sky. And that means that we're going to get to look at constellations that are actually visible, not just during the winter. So watch as I spin our view around and we look towards the north. I hope everybody can see it by now. I shouldn't have to tell you the name of the constellation, or to refresh a word that you just learned last week, asterism. The asterism that's present in the north. Does anybody see it? It kind of looks like a question mark at this time of year. Well, I'm looking at the chat, see if anybody wrote it down or said anything, but that, I don't think you see it yet, but it's right here. Oh, I see some chat windows just popped up.
Bobby, I see the question mark before you.
Oh, yeah.
Out.
So do you know what it is, Taylor?
No.
Oh, well, that is the Big Dipper. And let me give you a better view. Let me see if I can zoom in a little bit on that so we can look at it up close a little bit better.
Sure.
So to refresh a little bit about what we talked about last week, the Big Dipper is not an official constellation, although it's probably the one that most people know off the top of their head. If you ask them, what's a picture in the stars, the Big Dipper is probably the first one that comes to mind. It's technically not a constellation. It's an asterism that's a part of a larger constellation that you may remember is called Ursa Major, the Big Bear. We'll talk about the bear in a second, but let's start with the Dipper.
It has a long tail.
Yes, that is the weird thing about the bear. I know. It's so strange that this bear has a long tail because bears don't look like that normally. I promise we'll get into that story. But let's see, let me zoom out so that none of the stars are labeled. Right, so for most, this is the Big Dipper. And I wonder if any of the kids online, does anybody know any other names for the Big Dipper besides the Big Bear, Ursa Major that I just said?
The drinking gourd.
Oh, yes, I heard a whisper and then a loud answer. Yes, the drinking gourd. Now, this is an interesting concept. The drinking gourd and the Big Dipper probably come from the same idea. And the idea of this being a drinking utensil may very well have come to this country because of folks who were from West Africa who were taken in chains as slaves during the early time in American history. Because there is no European tradition of the Big Dipper, is thought to have come from Africa, where they saw it as a gourd on the west coast of Africa, and those folks who were imported as slaves to become America's African American community, they brought the memory of this African asterism, African concept with them, but it took on a very different meaning in the United States because during the time of slavery, many slaves sought their freedom on the Underground Railroad. Perhaps Harriet Tubman is the most famous person in this group of brave people who escaped from slavery. And a lot of folks realized that they could use the stars to navigate their way to freedom, even if they never had a map or a compass. And so the drinking gourd took on a very different meaning. And before I continue, I want to make sure, does everybody know what a gourd is? I should have brought a visual example with me, but I don't have a gourd on me. But you may have seen one decorating your table around Thanksgiving time. You can grow them in your garden. A gourd is a kind of squash with a hard shell. You cannot eat it. But if you hollow it out, you can make maracas out of it. You can make a birdhouse out of it or a Big Dipper out of it. And most gourds are round on one end where the seeds are, and they narrow to a tapered end that is where the stem attaches to the vine. They grow just like a squash or a pumpkin. So this gourd, if you can imagine it looking like a gourd, it would be a drinking gourd if you hollowed it out on one end and used it to scoop up water. So that's why that makes a lot of sense. And if you see a gourd, it really does look like the shape of this asterism. But the reason why it was so important during the time of the Underground Railroad was because of that famous song, I hope many of you have heard it, Follow the Drinking Gourd, that talks about how to use these stars to find your way to freedom. And the main chorus of the song is, if you follow that drinking gourd, for the old man is coming to carry you to freedom if you follow that drinking gourd. And so following the drinking gourd was basically saying, walk in the direction where you see these stars. And if I zoom out a little bit, you can see that right now it's in the northeast, but the drinking gourd is always somewhere in the northern sky. So no matter what season it is, it's in a very limited range that's always going to show you, it's always going to be easy to see in the northern direction. In fact, I think if I find the right button, I might be able to show you there. See that line that I just made appear is called the circumpolar circle? That is the group of stars that never set below our horizon. So you can see how the bottom of that circle touches the ground, and the top of it is where Capella is. Do you remember what I talked about last week? Anybody want to remember one of the funny things about Capella in the summer?
It goes along the ground.
Right. So if remember people when they see it low on the horizon, look at where the bottom of that blue circle is, and you can see that Capella at another time of the year could be visible right on the ground. And if you look at the Big Dipper, it also is always within that circle. So that means that there are times when it's low on the ground, there's times when it's high up in the sky, there's times when it's in the northeast, and there's times when it's in the northwest. But it's always in that circle, which means if you had no idea about which way you were going, you had no map, no compass, but you could see those stars, then you knew you were heading towards the north. And that is where you would hope to find freedom during the time of slavery in this country. So I hope you remember that story, because that's a very unique part of American history. And it's a way to always remember which direction to find the Big Dipper, the drinking gourd. So let me see if I can hold on a second. I'm going to take that circle out of the way. So drinking gourd, that's one name. Big Dipper, that's another. But you already heard me talk about Ursa Major. which is Latin for the big bear. And here is a classic illustration of what you might see in books. The bear with the freakishly long tail. Let me take that picture out so I can show you how you can actually see that bear with just the stars alone. It's actually the sun just came out and I'm having a hard time seeing the stars on my computer, ironically enough. But here, this bright star right here is, in my imagination, the nose of the bear. A star called Muscida. Maybe you think of mucus coming from the bear's nose. And here its eyes, and here its ears. Of course, this is all a matter of opinion. And you may decide you see the bear in a different way, but I think it's easy to make a little head with 2 eyes and a nose and a pair of ears out of these stars. However you want to see that head, you can see that here is a trio of stars that looks like it's the front chest of the bear, and then extending out from it are the stars that make the front paw. And the front paw, you can imagine, has bright claws. That's one of the easiest things to see when you're looking for that front leg, the claws, the bright stars that make it. And then let's go down and imagine that this is the length of the front leg, and here is the belly. And here's where we actually get to parts of the constellation, parts of the asterism, the Big Dipper. This is where they overlap, because this star is the bear's belly button. And if you can imagine that star is the bear's belly button, it's also the scoop end of the Big Dipper, the drinking gourd. So there's the bear's belly button. Belly button. Oh, that was a weird feedback. Somebody might want to turn on this. So I'm hearing a little feedback. Sounds like an echo of myself going over and over again. So here's the bear's belly button. Here's the bear's back. Or that's the scoop end of the Big Dipper that you would use to slurp your soup. So imagine that as the middle of the bear, but the end of the Big Dipper. And that's, I know why it gets confusing sometimes. So if that's the belly and that's the back of the bear, then here's its rear end. Yes, as a joke that I've told too many times in the planetarium, you don't want to drink that soup anymore once you realize that the Big Dipper scoop is the same as the big bear's butt. But there it is, a bear with a rectangular derriere. And there's its hind leg. And if we keep going down here, we can see 3 little stars. I like to think of them as the end of its big flat-footed hind paw. It kind of makes this triangle here that I see as the hind foot of the black bear. It's actually pretty close to the shape of a real bear's foot too. So there's the hind leg, the hind foot, the square rear end, the back, the belly, the chest, the front leg, and here is the head of Ursa Major, which of course leads me to the last part, which is the part that is always the hardest to explain, is why does this bear have this long tail? Now, I know some of the kids in the audience already know. Have you heard the story? Who wants to tell us the quick version? Anybody? It's all right. Everybody's quiet. That's okay. I'm looking at some of your previous chats, but nobody seems to be answering this one right off. Maybe I should turn off the sharing for a second so you guys can see me, because maybe this will make more sense if you see my hand gestures. But the story goes that that bear used to be a queen, and she didn't do anything wrong, but she had the misfortune of having Zeus fall in love with her. And that's a long story in Greek mythology. Zeus is always falling for mortal women. It's his weakness. So Zeus wanted to kiss the queen, but Zeus's wife saw that he was about to kiss another woman. And so in revenge, Hera, Zeus's wife, turned this poor queen named Callisto into a bear. And to make a long story short, after the story was over, Zeus wanted to make sure that people didn't forget this bear that was a queen that transformed because of his misdeeds and his bad acts. So he took that bear and grabbed her by the tail and swung her around his head so many times. He got her up to speed so he could launch her into space. And she became a constellation, but by the time he let go of her short, teeny, tiny, stumpy little normal-looking knob-like bear tail, well, you can see what happened. It got totally stretched out. And that is a part of the Greek tale about the long-tailed bear in the northern sky, which brings me to the fact that there is another bear with a long tail right next to Mama Bear. And that's the constellation. Well, I know it's a little crowded right here. You've got little Simba over here, Leo Minor, and you got the Lynx up there. You've got Big Leo over there. You've got Virgo, Persephone here. So let's not get all confused. Let's focus on the two bears, Ursa Major and Ursa Minor. So, does anyone, oh, I see a chat coming through. Hold on a second. See if anybody's got a question for me. Okay, well, does anybody know let me take off these pictures from Stellarium and have anybody tell me if they know another name for the little bear. Hint, hint. Look at the lines that appear.
Little Dipper.
That is the same as the Little Dipper. So the big bear is the Big Dipper, and the little bear is also the Little Dipper. And the Little Dipper is pretty easy to see. Here it's its brightest stars, but notice the name of this star, Polaris. Oh, unfortunately, all that other stuff just popped up. I'm going to try to take that out of the screen. But I think many of you might recognize Polaris as, any hint?
The North Star.
The North Star, exactly. So an easier way to find it is to remember the belly button on the back of the big bear, or the scoop end of the Big Dipper that you were going to use to drink your soup until you realized how close it is to the bear's butt. Well, these two stars, if you draw an imaginary line through them, they point you right towards Polaris. So even before you get to learn this constellation, you should learn how to find the North Star, and that could save your life. And also the proximity of the Big Dipper, or the drinking gourd, to the North Star should also help you understand that story. Well, wait a minute. Stellarium's doing something funny. I got to figure out what it is. Oh, yeah, I thought so. Tonight, the International Space Station is going to be visible. And I wasn't even planning on talking about that, but this is a simulation of how bright it's going to be. And according to this, it's going to be around 8:20 tonight, if the skies are clear in the north, that you might see the ISS. So I don't want to take away from the constellations, but I did want to address that because I bet some of you were about to report it as a UFO. But that is how bright the International Space Station looks when it crosses our sky. And it does cross it within a few minutes. So you might see it, and you might think that it's as bright as planet Venus, which it is. It's actually brighter than planet Venus sometimes. So if you see Venus in the west, and then you look towards the north, and you see another Venus, that's not another Venus. That's the International Space Station. Just think about the fact that there are people sitting in there, usually 6 at a time. The whole thing is going 17,500 miles an hour. And people have been living continuously in the space station in rotating ships for 20 years. So humans have been living in that space station for 20 years continuously without ever having to abandon it for any reason. So that's pretty cool. And if you do have clear skies tonight, look out for that. And I can show you some websites that'll help you track the ISS. If you want to figure out when it's going to be visible, all you got to do is punch in your zip code to websites like Heavens Above, and they'll tell you the next time you'll have a chance to see the ISS. But it's trying to photobomb our class right now. So I'm going to move back to the Little Dipper and maybe zoom in a little bit more. Just remember that that ISS is out there, and don't call the Air Force to report aliens, okay? So there's the Little Dipper, also known as Ursa Minor. The end of the handle of the Little Dipper is the North Star, and that is very useful. That could save your life. But if you want to see this as a Little Dipper, that's pretty easy. There's the handle, and there's the scoop. If you want to see it as a little bear, we'll pretend that this bright star called Kochab, which means the guardian in Arabic, that star is the head of the little bear. And there's his front leg, there's his back leg. So this little bear doesn't have much to him. He's just a few little dots to make his body shape. And then he has a long tail too. What is going on? Well, what I didn't tell you in that story about Zeus and Callisto was that Arcus, her son, got turned into a bear and also got thrown up into the sky, just like his mom, Callisto. And this baby bear, Arcus, the cub that was a prince that got turned into a bear and then got tossed into the sky where his tail got stretched out. Well, Arcus, that name should sound familiar to you because Arcus is the reason why we call everything in the north Arctic. So think of Arcus as the Arctic little bear, and he's next to his big mama bear, who originally was known as Callisto. And Callisto and Arcus are the actual names of Ursa Major and Ursa Minor. And if you learn these two constellations, you will have the chance to see them every single night of the year. They're always visible no matter what season it is from our latitude here in Vermont. So those of you folks watching out on YouTube, we're about 44.5 degrees north latitude. So if you live close to that, you can also see them every night of the year. But if you live farther south, they might disappear, especially the big bear, from your view. So now it brings me to talk about another constellation that some of you may have noticed was lurking next to the bears. Unfortunately, it's not the best time of year to see it, but we are starting to come into the time when we can see the oldest known constellation in human history. Maybe I'm gonna stay up a little bit later with you guys so that we can see him more easily, because right now in here, it's only about 8:24. So if you look at the clock, I'm gonna advance time and notice what happens with the sky. I'm gonna zoom out a little bit. And notice there's little satellites going by. Stellarium has added all this new data, which is great, but it's also sometimes a little distracting. But look, we're getting close to 9, so it's about 10 minutes to 9. I'm gonna go a little faster and I want you to notice something funny. Do you see that there's one star that's not moving? That is Polaris, because none of the stars are moving. It looks like our sky is moving, but it's actually our planet going, whoa, that way. So it makes everything look like it's going the opposite direction. But now that it's, well, 1:20 in the morning, sorry guys, you should be in bed. What are you still doing awake? The reason why I advance this to this time is to show you a constellation that's easier to see in the summer than in the winter. And it's the oldest one in human history. I wonder if anybody knows off the top of their head who I'm talking about. A constellation that was first drawn by people who lived 6,000 years ago. And they were the people who first wrote things down. They invented writing. And so this goes back to the beginning of history, the first written things that humans wrote down. Among them is the description of Draco, the dragon.
Ooh. Here's one I like.
So I'm gonna take some of these lines out, but Draco, one way to find him is to look at the fact that his tail goes right in between the two dippers or the two bears. So if you know where the dippers are, then you know where Draco is too. And Draco's tail is the easiest part to find at this time of year. The head part will be around till midnight tonight. But I definitely want you to know about Draco so that you can be ready to see it during the spring and summer when it's easier to see. So let me take some of these pictures out and show you how to see Draco with just the stars alone. There's the Little Dipper again. Hope you remember that. And the Big Dipper. And can you see the stars that make Draco's tail that run right here in between the two dippers? That's a pretty easy thing to find. And then if you follow that tail, it winds like a big semicircle around where the Little Dipper is. Oops, sorry about that. So there's Little Dipper. Here's the arc of the tail of the dragon. And here are his legs. I see 4 legs, 2 in the front. And then here's one of the hind legs. And here's the other hind leg. Of course, this is all up to your imagination, but out of this group of stars, it's easy to make what looks like 4 short legs. And then here is the best part of Draco. The pièce de résistance of this constellation is his head, because he's got two eyes that stare right at you. Stars with cool names. Rastaban is his right eye, and his left eye is El-Tanin. So you don't need to remember those names, but they're Arabic words too. And if I take those highlights out, it's really cool because there aren't that many constellations that look like they're looking at you. Draco is looking right at us whenever we see this constellation. If you add this as the tip of his nose, a star called Grumium, and then you could pretend that this is the tip of his pointy head there. That's how I see him in my imagination. But technically, that star belongs to Hercules. So we won't get into a fight with him over that. But remember the whole difference between a constellation and a star picture. So there's the head of the dragon, his two twinkling eyes, his top of his pointy head, the tip of his nose. And I don't know, what should we make this star? A tongue sticking out? Maybe a small flame squirting out of his mouth? But that diamond is really easy to see. And then once you found the legs, you can also easily find the tail. And that's between the Big Dipper and the Little Dipper. So just imagine this. Draco is a 6,000-year-old concept that people are still talking about today. He's a meme that's 6,000 years old. It's kind of crazy to imagine that people 6,000 years ago spoke a different language than we do. They lived in a different continent than I do now, but they still could see that same dragon in the sky. It's pretty cool to put yourself in touch with people that lived that long ago and try to imagine what their lives were like based on the things that they imagined being in the sky. It's also cool to think that dragons have been popular for that long. You know, they didn't have Game of Thrones back then, but they had Draco. So let me know, does anybody have any questions? It's been quiet from the students, and I've been talking for a while. I wanted to make sure we have a chance, so I'm going to stop the sharing of the sky for just a second. I'm going to back up for a second and see if anybody, I don't see anything in the Q&A.
I sent one to you in the chat.
I just see that. Yes, somebody asked, what is the newest known constellation? Ooh, that
Bobby, what did you just say you were going?
Well, I was trying to answer the question. The question is, what is the newest known constellation?
What? Wait, I can't understand you. You've been going in and out for the past little while.
Oh, I'm sorry, bud. There's only so much I can do about that. I can't really control that. That's going to be up to the internet and what it's like wherever you live and where we are here. So I'm sorry if the quality is choppy. But what I'm trying to answer is, what's the newest known constellation? And for that, I'm going to zoom out on Stellarium. Let me put a screen sharing for a second, because there's something cool that you can do with Stellarium that you can't do in your backyard, which is that you can see what the sky looks like in other continents, in other parts of the world. So I'm going to put up all the pictures for a second and all the names. And you can see that a lot of these are, you know, concepts that are very ancient. Draco the dragon, we've got a bear, we've got a giraffe. There's nothing new here. But if I take the ground out of the picture, now we're looking at the southern hemisphere. Southern hemisphere. So the stars that are visible now. Oh, yeah, somebody's got to turn down. I'm getting a feedback effect right now. So I don't know whose that is, but if you could turn that down, please. So look at the constellations that are visible from the southern hemisphere. If you look at the names or at the pictures, you might notice there's some things here that are not very ancient. For example, telescopium. Huh? Those didn't even exist 6,000 years ago. In fact, the first telescopes used in astronomy were used 409 years ago. Galileo used his telescope. It's been only a couple centuries that we've had telescopes and microscopes. So it's obvious that these are not ancient constellations. So I'll tell you this, that the constellations that we know, the official 88, they were made up by people mostly from Europe. And they had not sailed to the southern hemisphere until like the 1700s. So there were people that you may have heard of, like Edmund Halley and the guy who discovered Uranus, William Herschel. They were some of the people involved with naming these southern constellations because they lived in the time during the British Empire when the British Navy had ships that could sail around the world. And when they sailed into the southern hemisphere to colonize places like Australia, for example, and South Africa, they saw constellations that they weren't used to seeing back in Europe. And so people like William Herschel and Edmund Halley and other astronomers from the 1700s started naming these constellations. So they started using names that come from their own time, like a telescope or a microscope. And that is in contrast to the constellations of the north, which were named in ancient times during the time of the Greek Empire or the Egyptian Empire, many thousands of years before. So the Egyptians didn't use microscopes when they built the pyramids, and they wouldn't have seen a microscope in the stars 5,000 years ago when they were busy building the pyramids. So I hope that answers the question. I can't tell you exactly what the newest constellation is, but I can tell you that the newest ones are all in the southern hemisphere's view, and we don't see them from where we live because of the Earth being in the way. Or in this view, it looks like you're stuck in the bottom of a well. So, anybody else have a question? Please do ask anything. There's so much information in this sky, I know it can seem overwhelming. So when it comes to learning new constellations like Draco or Ursa Major and Ursa Minor, you know, go easy on yourself. Don't expect yourself to memorize them on your first try, your first night. It might take weeks, it might take months before you are confident about how to find them. But you have to try, you got to go out there. So take advantage of our clear skies and the rural environment that we live in. And when there's a night without a moon, you probably can see most of the stars. People who live in cities don't get that advantage. So take advantage of the wonderful conditions that we have here. And please try to find these constellations. It's going to take practice, but I'm sure if you go out every night that is clear, within a month, you'll be an expert on seeing them. But I'm going to talk about some more things in the sky, unless I see any other questions. Let's see. I haven't seen any new questions. Does anybody want to ask anything, either on the mic or through the chat window?
Wasn't there one about a cow? Maybe it got taken out. Oh, like a story. Oh. Yeah, B was asking a story about on like yes. A cow.
Okay, this is for B's question. This is all about Zeus. I'm embarrassed to say this, Zeus, but I mean to say this about Zeus to you, B. But Zeus is not a good role model for any man, okay? Those stories of Zeus are all about him falling in love with a poor, unknowing, unsuspecting mortal woman, and usually it involves him abducting her somehow, kidnapping her to try to trick her into being his lover. So in the case of the cow, yes, there is a story about Europa, a beautiful princess from the island of Crete that was kidnapped by Zeus when he converted himself into a bull. And he dressed up like a bull with woolly white fur and golden horns. And she was from a culture that valued their cattle. So as a farm girl, Europa saw this bull out in the pasture and was amazed and had to get close, had to see what it was all about. And it turned out it was Zeus in a disguise. And he abducted her and carried her on his back across the water from Crete to the continent that is now Europa, which is, of course, Europe, which is a little bit of a funny story because when we get into studying the planets, you're going to discover that there is a moon around Jupiter called Europa, and there's a moon around Jupiter named Callisto. And Callisto was the original name of the woman who became the bear. And then I have to tell you that all of the moons of Jupiter are named after people that got into affairs with Zeus. And there's over 75 named moons of Jupiter, and they still have not run out of names of victims of Zeus, you could say, to name the moons after. So there are many stories in Greek mythology about Zeus behaving in ways that I would definitely not recommend. So does that answer your question, B? I think you now know where all of this comes from. Matthew, why are you asking us what 2 times 2 is?
Tell him.
Did your sister
4.
do that? Did your sister do that to you? So, all right. I'm going to continue on with some more constellations, unless anybody has any questions.
What's the oldest constellation?
Oh, that one I already said. If you remember, it was Draco, the dragon. That doesn't mean it's the first one that humans invented. Who knows how many prehistoric constellations there must have been. Think of all of the pictures that people sitting by campfires must have imagined over the last hundreds of thousands of years of human history. But what I say by oldest constellation is, I mean, the oldest one that we have a written record for. And that is Draco the dragon at 6,000 years old. And of course, I know many of you are Harry Potter fans. Yes, that is where Draco Malfoy's name comes from. Just like so many other star names and constellation names that you hear if you're fans of J.K. Rowling's books about the teenage wizard Harry Potter, like Sirius and Bellatrix and Regulus and Draco. These are all characters, but they're also stars and constellations. So it's a fun way to connect what you're learning now to something you may already know.
And we had one more about Beetlejuice. No, I'm going to say Beetle. I'm going to say it wrong.
Beetlejuice, when will Beetlejuice blow up? Well, I think I know where this is prompted from. And just to remind everybody, I'm going to go back to sharing the screen at Beetlejuice. So that's a constellation, that's in the constellation of Orion. And we talked about him last week, but let's go back. It doesn't hurt to look again. Oh, wait. Unfortunately, I kept you guys up so late. Let me show you how you can do this easily with the clock functions. If you're using Stellarium, you can open up this little date and time window, and you can jump back a few hours if you want, or a couple of days. Let me go back to a decent time of night, 9:30, when Orion is still easily seen. And there's Betelgeuse, a star whose name means the armpit of the Great One. The armpit of, see, right in his armpit, see? But I'm not going to go into all the different ways to see Orion, but this star is one of the ones that has been fascinating astronomers greatly as of late because of the fact that its brightness dimmed so much that you could tell with the naked eye that Betelgeuse was dimmer than it was years before. If you're an astronomer and if you've been looking at the sky your whole life, you know that Betelgeuse used to be almost as bright as Rigel, and now lately, although it still looks like that in this program, for the last few years, Betelgeuse has dimmed by up to 50%. And that's an interesting thing. I want to point out something about Betelgeuse. If you look at where it says distance here, it's 497, almost 498 light years away. So anything that you see happening on Betelgeuse actually happened 498 years ago. Does that make sense? So if Betelgeuse got dim all of a sudden, it didn't happen just now. It happened almost 500 years ago, and we're just finding out. That's because the light from Betelgeuse takes almost 500 years to reach us. So that's why we call it 497 light years away. Light is going 186,000 miles per second, 671 million miles an hour, and it still takes 498 years to get to from Betelgeuse. A star that's called a red supergiant. It is the kind of star that is very likely to explode in a supernova sometime in the next few million years. So I don't want you to hold your breath and wait for Betelgeuse to blow up. But Betelgeuse could possibly explode tonight, which means if it explodes tonight, that means it actually happened 498 years ago. And if Betelgeuse did do a supernova, if it did blow up, it would be almost as bright as the sun in the sky for a few hours. In daytime, even when it wasn't dark, it would look like a little, like a mini sun in the sky. And then eventually over time, it would fade to the point where you'd need a telescope to see it. But there has not been a supernova of that kind in modern history. So nobody alive today has ever seen a star blow up in quite the way that Betelgeuse might. But I can give you a little bit of a sneak preview if you want to imagine what that could look like. I'm going to stop the screen share for a second because I have another picture I want to show you. Here is a picture that was made in 1054 AD. That is the last time that a supernova visible to the daytime sky happened. But in 1054 AD, nobody on Earth knew what a supernova was. So people had no idea what this was, except that it was so bright that it was visible during the daytime. And this picture is a picture from a German painter who was painting a trip that King Heinrich III made to Tivoli during that time. It happened to be July the 4th, which back then was not yet an American holiday because America as a country did not even exist yet. But it's an interesting thing that there were fireworks on the 4th of July in 1054 AD during medieval times, back before people knew how to paint buildings and people in proportion, as you can see here. So I'm going to stop that share. Just imagine if Betelgeuse did that to us tonight. Well, astronomers who've been studying Betelgeuse noticed that it's actually starting to get bright again, and they're starting to think that maybe it wasn't a sign that it was about to explode, but it might be an indicator of the fact that Betelgeuse could be in a very dusty star system, meaning that it's a solar system. It's like the sun in the center of its own system, but it's probably got a lot of debris and a lot of gas and a lot of dust orbiting around it, which is what made it look like it was dimming. So if you were hoping for Betelgeuse to explode, it could happen tonight. It could also happen anytime in the next 100,000 years. So don't hold your breath.
If Betelgeuse blows up, what will happen to the constellation of Orion?
Well, he'll be all armpit for a while. Meaning, well, that part of the sky will be so bright, it would be brighter than having a full moon in that direction. So you can imagine that if Betelgeuse is here and it became that bright, then it would probably wash out your ability to see everything else nearby. You might even have a hard time seeing Sirius, if you can imagine that. But I'm just guessing now because really nobody around today has ever seen a star explode in that particular way that close to us. The most recent supernova that was close enough to the Earth to be seen with telescopes was in 1987. That one was pretty impressive, but you still needed a telescope to see it. And that is because it happened in a nearby galaxy. It didn't even happen in our own galaxy. But if our own galaxy's nearby star Betelgeuse did explode, nobody would need a telescope to see it. You would know it right away. Oh, I see a new question coming in. Hold on a second. So Lily asked if it would be as bright as the sun at night. Not quite as bright as the sun, but based on the anecdotal stories that we have from people who lived in 1054, they could see their shadow on the ground by the light of that supernova. So it wouldn't be as bright as the sun, but it would probably be brighter than the full moon. So that's probably a good way to kind of imagine the range of light that it could give. And it would last for several weeks. So our nighttime sky would be really weird for a while if that were to happen. I'm pretty sure we'll know because as soon as that happens, it's going to be all over Instagram. You know, everybody's going to be posting it. If it ever does happen, you will know if Betelgeuse blows up. You won't need me to tell you. So that's a good question. It's a little bit of a recap of what we talked about last week with that side of the sky. But I want to continue now a little bit more exploration of the stuff in the north that you can see tonight. Now, there's a pair of constellations that are easily seen in the north tonight, but they're on the opposite side of the North Star from the Big Dipper. So maybe I'll put up those lines again so you can see there's the Big Dipper. And here's how we find the North Star on the tail of Ursa Minor. There's Draco that we just covered a bit ago. I'll go past the North Star and talk about a royal family that lives in the heavens. Cassiopeia and Cepheus. Cassiopeia is definitely the easier one of these two to see. And if I take away that name, I'm going to zoom in on Cassiopeia. I think you might recognize her. Let me see if I can get it without the labels of the stars. So when most people see Cassiopeia, they see it as this zigzag shape. But if you know the ancient mythology, Cassiopeia was the queen of Abyssinia, which is the part of Africa that we know as Ethiopia today, in East Africa. Back in ancient Greek times, Ethiopia, also known as the Empire of Axum or Abyssinia, was one of the major trading partners with the ancient Greek Empire. So this story kind of symbolizes that, because some of the characters in the story are African and from Ethiopia, and some of the story's characters are Greek. So it's kind of a cool intercontinental, international love story. But it starts with this throne right here. So I'm put up the little highlights. You can see the zigzag bright stars. But Cassiopeia isn't really a person. She's supposed to be represented by a chair. So if you look at those stars a little differently, you might see how you can make a chair out of the stars. Here's the top of the chair where you'd rest your shoulders. There's the back of the chair that you'd rest your spine against. And here are the stars that make the seat, where there's a nice cushy for the queen's tushy right here. So see how those 4 stars make a nice trapezoid? Does that look like a chair seat?
No.
Come on, have some imagination. Here's the back leg of the chair, and here's 2 of the front legs. So the 2 front legs are here, the seat is here, here's the back leg, and if you add this all together, I think it does look like a 3-dimensional chair.
I'm using my imagination.
What's that?
I'm using my imagination. I can see it.
Yay. All right. So that chair has no queen sitting in it. Well, that's because she refused to put the royal seatbelt on and she fell out of that chair a long time ago. That's actually a part of the story. It's because Cassiopeia is one of the many mortals that received punishment from the gods because of her hubris. Another great Greek word, when people had too much pride and they thought too highly of themselves and were arrogant, thought that they were invincible, or maybe that they were as powerful as the gods. In the Greek stories, the gods have a way of humbling people and putting them in place. You say Cassiopeia was to be put in the sky in her chair, but because this part of the sky turns as the night goes on, her first night in the chair, she fell out. So sad to say, Cassiopeia is kind of like an astronomical version of that clown in the dunking tank at the fair. She fell out of the chair into the ocean, and she's doomed from that. But you can still see the chair that she fell out of in that cruel kind of story. But she's right next to her husband, known as Cepheus. And Cepheus is supposed to be the king in the story of Cassiopeia. He's not as much an important character as the queen, but when I look at the constellation Cepheus, what I want you to imagine is that it looks like the way a little kid would draw a house. Can you see that? The square is like the walls of the house, and the triangle is sort of like the roof of the house. So if you can see that general shape right there, I've made it with the illustrated lines. You can see how it looks like a house. But how does it look like a king? Well, I happen to think that this triangle roof is actually a pretty good crown. And this square for his head is his blockhead right there. And you could pretend that these stars make a little goatee on his chin, perhaps. Maybe that's his eye looking in the direction of his queen's throne. Here's Cassiopeia. And behind his head, if you can imagine, back here, you can pretend that these are like a ponytail or some braids or dreadlocks hanging out the back of his head. But just imagine that that's a head facing the queen, and you can see Cepheus the way I see him. But he's not as famous as Cassiopeia is in the story. And if you look at them together, you can see where they sit next to the other constellations that we've been talking about. So tonight, they'll be low in the sky, but you can see them easily. And then if you use Cassiopeia as your guide, I'm going to show you how you can also see the character that is the hero of this story. I want to ask, does anybody know off the top of their head? Oh, I just gave you the hint. I accidentally revealed the answer. Does anybody know a famous Greek hero that plays into the story of Cassiopeia and Cepheus? He's right there. You don't see him? Well, I know this is tough. This is a difficult constellation to see. It's very distinctive, but it's not easily seen with the stars, except it's got like a constellation within a constellation. Right here, let me start with this. This little part of the constellation I'm talking about represents the head of an evil sorceress. She had a magic power. Her evil eye, this star, if you looked at it, it would turn you into stone.
Medusa.
Yes, this is Medusa's eye. Now here, check this out. Algol is the name that we know in astronomy from the Arab astronomers that named it. And Algol means the ghoul in Arabic. That's a pretty good name for somebody like Medusa. But look at what the Romans used to call this star, Gorgonea Prima. Now, if you know your mythology, the Gorgons were the name of Medusa and her sisters that all had that crazy serpentine hairdo. So Prima Gorgonea means first Gorgon. And that just goes to show you that this star has always been, since ancient times, associated with Medusa. So let me go give you a little detail. There's Algol. I'm zooming in. I hope you can still see the stars around it. Pretend that that's an eye, and that's another eye, and these are two flared nostrils, and these stars all around are the little heads of the snakes that make her hair. So altogether, it looks a little bit like a mushroom, or maybe one of those Mario Brothers characters like a Goomba, something like that. That's the head of Medusa. But I got to tell you the story about Algol, because Algol takes ancient knowledge and puts it right into the modern scientific understanding. Algol is a variable star. And those of you who haven't heard about that, it's a kind of star that changes its brightness dramatically. It basically doubles in brightness, and then it goes to half its brightness on a period of every 2 3/4 days. 2.75 days. It's a weird time period, but it's a very distinctive time period. And some archaeologists from came to England digging in an Egyptian tomb, and they found that this tomb, which belonged to a merchant, had a big chart that had all the days of and all the nights of the year listed on it, and it had days and nights that were good days and bad days to do business. You could say lucky days and unlucky days. And when the archaeologists from Cambridge studied the chart, they recognized that the repetition of the pattern of unlucky days and lucky days coincided with the brightness of Algol. So basically, ancient Egyptians thought that this star was an evil eye too. And they believed that when it was bright, meaning that the eye was open looking at you, that was a bad day to do business because bad things would happen. They were superstitious about this star. But when that star was dim, which is most of the time, they thought, okay, it's safe to do business. It's not going to be a bad time, which is really weird because it shows that they thought this star was cursed somehow. And that's a lot like the story of Medusa, that if she looks at you, you turn to stone. Talk about bad luck. So the idea of this star having something evil about it goes earlier than the Greek Empire and earlier than the Greek civilization to the ancient Egyptians who knows how long ago they noticed that this was a variable star, because variable stars are modern astronomy. Now we understand this. And if you look at the top of the description, it says type, eclipsing binary system, double star. So before I tell you what that means, I wonder if any of the kids can kind of guess as to what actually makes this star get brighter and dimmer. Take a guess. Is the star just inflating and deflating, getting brighter and dimmer? Or could that toad I see. I get your reference, Matthew. Yes. Like a Goomba or like Toad from the Mario world. You could say that Medusa looks like Toad. But who wants to take a shot at trying to figure out what that means? Eclipsing binary system, double star. Maybe if you think of Luke Skywalker on Tatooine, that could give you a hint. So quiet. I thought it's too early to hear crickets. No guesses? Okay, two suns. All right, Sadie. Yes. But why would they get brighter and dimmer? Matthew, you're snoring. It's not a good sign. So I'll give it to you guys since you're not jumping at the chance to try to guess this. This is a double star. When it's doubly bright, it's because we can see both of them. Yes, Sadie, you got it right. They get brighter when they get side by side. So when both of them are lined up so that we can see them from the Earth, it looks like the star is twice as bright. But then when they go around each other, one of the stars can block the light of the other. So Algol is blinking bright and dim because basically you're going from seeing one star to seeing two stars to seeing one star to seeing two, and their orbital period is 2 3/4 days, 2.75 days. So it's a pretty cool thing that people noticed in, prehistoric times. They noticed that long before they had telescopes, just by looking at the sky. So I want to ask you guys as a challenge, do you think you would notice that if you were looking at the sky every night? Like, do you think you look at the sky enough to notice that there's a star that's dimming and brightening? Think about what that means. Talk about dedication. So all that talk about Algol, and that's just one star of the constellation called Perseus. So check them out. Holding, it's a pretty gory picture. Sorry, kids. Not a G-rated constellation. So Perseus, does anybody know the story behind him before I go into that? And I'll show you how to see him. He's not that easy to see. You can see that he's holding Toad's head, Medusa, right there. But the rest of him is kind of a jumble of stuff. Up here is what looks like a helmet or a pointy hat on his head. See that triangle? And here is his very long face. You'd have a long face too if you just killed Medusa. And here's his brightest star, a star called Mirfak. But I like to see that as kind of his shoulder. And here is his arm. And do you see how the stars that make his arm look like they're curled up? I like to pretend that he's flexing his biceps, trying to show off his muscles. Typical hero thing to do. And there, down here is his body, and here is his long leg with his foot right there. And that foot is probably the best that you can see for the rest of him. So he's got Medusa and a long chain of stars that make a kind of skinny body with a pointy head and a curled up arm flexing off his biceps. So you can see that this picture that they provided with Stellarium sort of matches what's there, but it doesn't really help you see the stars. Although they did line up Medusa's eye nicely with Algol, the rest of the picture doesn't really match the stars that well. But when you see a line like this, you can see why. There isn't that much detail with Perseus. It's very much an imaginary constellation. You're gonna have to do a lot of work to make that picture. But another thing that's interesting about Perseus is that he's right next to the Seven Sisters. So if we zoom out a little bit, you can see how his body stretches from the northern sky towards the western sky. And the western sky is where we got the Seven Sisters that we talked about last time that are part of Taurus the bull. So you've got Perseus, you've got Cassiopeia, you've got Cepheus in the north, you've got the Big Dipper, you've got the Little Dipper, you've got the dragon all hanging out in the north in this direction. Oh, and they have a nice little picture of Cepheus, although that doesn't match the picture I see. There's the Ethiopian king and his queen. So remember, we talked about this last time. Just because you see an illustration of a constellation doesn't mean that that's the way you have to see it. The folks that did the artwork for Stellarium made some choices, but that means you have the power to make those same choices yourself, and you can say, nah, that picture doesn't fit. I like to see it this way instead. It's always optional. It's always up to you and your imagination. So don't let a picture in a book that doesn't match up with the stars, you know, get you disappointed. Don't let that stop you from enjoying these constellations. But I want to mention another constellation too, but let me see if there's any other questions from any of you folks. I know we've been doing this for a while, so I'm going to stop the share Stellarium. We're about an hour into our lesson here. That's a long time for anybody to be sitting and listening and watching. So maybe all of you should take this moment to stand up and stretch. Reach for the stars up above your head and just give yourself a chance to flex and think a little bit. And I hope that some of you can come up with some good questions to ask me. I would love to answer your questions, but I need to get questions to answer them.
There is one that I sent to you about if a star blew up, would it release gamma rays power enough to destroy the planet?
Ah, well, Leila, now you're going to make them all nervous.
It was just somebody posted on YouTube, so I thought I'd upload it.
No, I'm glad you did. I'm sorry I missed that question. I didn't see it until now, but it is possible. Every time a supernova happens, it generates a lot of gamma rays. And gamma rays are not just the thing that turned Dr. Banner into the Incredible Hulk. Okay, gamma rays are what comes out of an atomic bomb when it goes off. And gamma rays destroy molecules and atoms, meaning they destroy us and DNA and everything else that we love. So obviously, we do not want anything that gives off gamma rays to be anywhere near the Earth. The good news is that gamma ray radiation is absorbed by the atmosphere, and the gamma rays that are already hitting the Earth from other supernovas that have happened already don't make it to the ground. Our atmosphere takes the hit, and the gases at the top layer absorb all those gamma rays, and the gamma rays light turns some of the molecules into different forms. It smashes atoms, creates new molecules, but all that happens about 100 miles above your head, and very little of that can ever reach the ground. However, if the star was very close to us, the gamma ray flux could be so high that it could hurt us, but there are no stars near enough to happen. No are close enough to be a threat to life on Earth. So look at it that way. We've been doing astronomy with telescopes for more than 400 years. We've discovered that there are stars that can blow up, but we can relax and say none of the ones that can blow up are close enough to us that we need to be concerned. But it would be quite a light show, just not a dangerous light show. However, just imagine if you were on a planet going around a star that was going to go supernova. That would be a whole nother story. You would not survive that. A planet going around a star that supernovas would just be evaporated. It would turn into gas. It would be so hot that it wouldn't even melt. It would just go poof, like what Thanos did to all the Avengers, like that. However, the sun's not going to do that. So if you're starting to worry, looking at the sun through the clouds, thinking, is the sun going to do that to us? The sun cannot. The sun is a type of star that is far too small to do a supernova explosion. So let's be glad about that. The sun would have to be at least 8 times bigger in mass to even have a chance at doing a supernova. So since the sun's not getting any larger, we don't have to worry about this. We are not going to be the victim of a supernova, but I would hope that in our lifetimes, we get to see one of those, maybe not Betelgeuse, maybe another star will surprise us, and we will get to see what those folks got to see in 1054 AD. That would be cool, and that would not necessarily be something that could harm you at all, unless you were really close to the star. So I hope that answers that question, and I hope that assuages any fear that anybody might have about a supernova gobbling you up. No, you don't have to worry about that. We've got enough things to worry about nowadays. You don't need to add supernovas to the list of concerns. So anybody else have any questions? I hope everybody's stretched. I didn't hear that many squeaking floorboards and creaking chairs, but I hope all of you, are ready to keep going on these stars. Let me know if there's any other questions that you're curious about. We can talk about other topics in astronomy as well. We don't have to just do constellations, but you guys can let me know by your questions on the chat window. I'm gonna No questions? Oh. Well, let me show you something else real quick. That supernova that I mentioned that was seen in 1054 AD, it wasn't seen just by the folks in Germany that made that painting. Here's the painting. I think you can see it floating around on my desktop now. That is a painting from Europe, but at the same time that that painting was being made, people were living in a place in New Mexico called Chaco Canyon. And right here on the wall is a petroglyph, a drawing made onto stone of something that looks a lot like that. Archaeologists have debated about whether or not this is actually a depiction of the same supernova. But the other interesting clue is that we know that on July 4th, 1054 AD, there was a crescent moon in the sky. So it's not direct evidence, it's more like circumstantial evidence, but it's a very likely thing that this is a depiction of what this is too. And they look very similar. And let me just give you a little bit more background. I'm gonna put up a picture of where that is. If you ever go to New Mexico, go visit the Chaco Canyon National Park and you will see.
We used to live in New Mexico.
Oh, did you ever go there?
No.
Ah, well, the petroglyph that I'm talking about is somewhere in the background back here where there used to be houses. I think it's inside of a ruined building that was a house. But this part in the center is a kiva, which was a place where they held ceremonies, was roofed. So it's sort of like an underground, under roof shelter that was sort of like the town square where the main things would be happening on a daily basis, religious ceremonies, probably weddings and funerals, who knows what used to happen in this city, because this civilization had abandoned this place before the Spanish conquistadors came to New Mexico. So we don't really know much about the Anasazi civilization, but we know that they built amazing buildings near cliffs in New Mexico. Maybe they left us a petroglyph of a supernova from almost 1,000 years ago. So some of the cool things that astronomy leads you to. You never know. Astronomy covers so many subjects that you end up learning archaeology and history and even art in the process of trying to make sense of the sky. So that's one of the reasons why I love this discipline, because it really, astronomy touches every other subject that humans know, in addition to the stars. So, any questions about that? All right. Well, here, let me bring us back to Stellarium. And let me talk about something that is actually not that easy to see right now, but something that you should know relative to what we were talking about, that royal family, Perseus, Cassiopeia, Cepheus. There's a constellation associated with them that is going out of sight for a few months, but you'll be able to see it easily again in the fall. And I'm going to take the ground out of the picture because I think you might know who I'm talking about. The constellation known as Andromeda. Anybody see something funny about this picture? Andromeda is supposed to be an African princess, but they always seem to depict her as looking like, a long-haired blonde, especially in that movie, The Clash of the Titans, which is supposed to be that story, but they get the characters' appearances all wrong for some crazy reason. However, Andromeda looks like she's in trouble. In fact, this picture shows her looking kind of naked, which is not necessarily part of the story. but Andromeda was the daughter of Cassiopeia and Cepheus. And remember I told you about Cassiopeia having hubris. Well, she was considered to be vain. Even this little picture has her shown looking into a mirror. Cassiopeia made a big mistake. She compared her beauty to that of the immortal Nereids. And the Nereids were the daughters of Poseidon, immortal little mermaids. And when they found out that this queen, who was merely a human, a mortal, was comparing herself to their beauty, they got mad and they told Poseidon, and Poseidon got furious, and he decided that he was going to destroy the entire kingdom of Abyssinia with a sea monster that we know as the constellation called Cetus. I'm not going to spend too much time showing you Cetus because he's also not that easily seen. As you can see why, he's out during the daytime. He's not visible at night tonight, but he is part of the story that I thought I should just include to give you the full picture here. Cetus, the sea monster, was sent to destroy Abyssinia because of Cassiopeia's vanity and her hubris. But at the last moment, Poseidon changed his mind and he decided that they would be a little bit overboard to destroy a whole kingdom. So instead, he thought he would offer, he would give him a choice. He said, you could let all of all of your kingdom be destroyed, or you can sacrifice your daughter Andromeda. So this is why Andromeda is depicted chained up on the rocks on the beach of her own kingdom. She is the original damsel in distress, the princess in trouble, needing to get rescued, just like Fiona in Shrek, just like Rapunzel in Tangled, just like Sleeping Beauty and Snow White and Princess Leia, who was trapped in the belly of a beast called the Death Star until somebody came to save her. And in the case of Andromeda, do you know who's coming to save her? Perseus. And do you know what weapon he's going to use to immobilize that giant monster whale?
The Hagrid.
Yes. So this is a story that if you study Greek mythology, you may have heard before. But what's cool about this story is that all of the characters are in the stars. Unfortunately, only half of the characters are visible tonight, but in the fall, you'll have a chance to see all of them together. And you can see the sea monster, you can see the princess, you can see the king and the queen, and the hero that dashes in at the last moment to save her. And how does the hero get there in time? Does he take an Uber? The bus? He rides there on Pegasus. So I know that talk about constellations that you're not going to be able to see tonight because they're going to be below the ground. But just know that when you look at Cassiopeia and Cepheus and Perseus, you're just looking at a part of the cast of a great epic story that lives in the stars. And one last thing about Andromeda. First, maybe somebody in the audience can tell me if they know anything else that's cool about Andromeda. Because there is one part that you might have a chance to see if you're out at the right time tonight. If you look at the time, I'm reversing time. Things are going backwards than they usually do in Stellarium, and I actually got it now so that it's showing us. Hold on a second. Can't see the clock. It's showing us around 8:30 tonight. So at 8:30, you might actually get to see Andromeda. Does anybody know anything else about her that's cool besides the picture in the stars? Nobody? So quiet. What about this? Does anybody know what that is?
Galaxy! A galaxy!
Yes, yes, thank you. There. Right in Andromeda, right on her waist, or her belt, so to speak, is the galaxy called Andromeda's Galaxy, and that is the farthest object that your human eye can see. What's cool about Stellarium is that it goes from what your eyes can see to what a telescope can see in a sort of a fluid motion. So if you zoom out, that's what your eye would see, a little fuzzy patch. And with a telescope like the Hubble Space Telescope, that's what we see. A galaxy that is actually bigger than the entire Milky Way, contains maybe up to 800 billion stars in it, and it's got two little baby galaxies orbiting around it. Think of these as like little bear cubs orbiting around a big mama bear. And all of this is visible tonight if you go out and look in the northwest just as soon as it gets dark. You might not see the whole constellation of Andromeda, only because part of her is invisible. Her head is kind of below the horizon or too close for you to be able to see her. So I wasn't really going to focus on the constellation form as much as I want you to be able to find the galaxy itself. And there's a little hint to finding that galaxy using the stuff that we already learned earlier. If you remember where the Big Dipper is, or Ursa Major, remember how to draw a line through these two stars, the belly button of the bear and its back, or the scoop on the end of the Big Dipper, the drinking gourd. Draw a straight line through those two stars and they lead you to where Polaris is. And then if you can do that, then it's pretty easy to find Cassiopeia. She's just on the opposite side of the North Star next to Cepheus. And then if you found Cassiopeia, then use the back leg of the Queen's throne, this part. See how it almost perfectly points right at Andromeda's galaxy. So if you can find the Cassiopeia constellation, that's all you need to find the Andromeda galaxy. And if you find the Andromeda galaxy, then you are literally looking back in time. You are looking at light that left that galaxy 2.5 million years ago. So this is 2.5 million light years away. And that means that that's not what Andromeda's galaxy looks like right now. If you want to see what it looks like right now, you're going to have to sit tight and wait 2.5 million years. So, remember Betelgeuse? Betelgeuse was 498 light years away. So Betelgeuse is within our own galaxy, less than 500 light years away. So what you see happening on Betelgeuse is actually what happened about 500 years ago. And then when you look with your own eyes at Andromeda's galaxy, you're looking at something from 2.5 million years ago. And that gives you an idea of how far away that galaxy is relative to a star like Betelgeuse. So anything that you see happening inside of the Andromeda galaxy happened before humanity even existed. How crazy is that? With your own eyes, you can look at light that is older than the species that you belong to. I don't think there's anything cooler to think about than that when you're looking at the sky. Hope that inspires some interesting questions from some of you folks. So I see Sadie asked if stars can have eclipses. Well, yeah, that's what Algol is. It's an eclipsing binary star. So it's kind of weird to think of an eclipse happening when both of the objects are very bright. But even if, well, my two fists, imagine if they were stars. If this one was very bright and this one was very bright, it doesn't matter if this one is very bright if you can't see it because it's blocked by the light of another one. So even though this is bright, it's also blocking this light. So that's when Algol would look dim, and when Algol would look bright, it's got both stars facing you. And then when it goes around the other way again, it gets dim again. So imagine two stars doing this every 2.75 days. Dim, bright, dim, bright, dim, bright. And then you get the idea of how some variable stars can happen. And I wasn't going to go into the deep details of this, but there are other kinds of variable stars. Some variable stars are not really varying their light. They're just going around each other like this. But there are other stars that actually go dim and then puff up and become very bright and then dip down again and dim and brighten and dim. Almost like they're inflating and deflating like some giant cosmic balloon. And those stars also vary in their brightness. They're variable stars, but they're of a different nature. And there's actually a category of variable stars that are very important to the history of astronomy. They're called Cepheid variables. Does anybody recognize that name? Cepheid? What does that mean? Have you ever noticed that things that are named after constellations have funny versions of the names? Like there's a meteor shower that we see in Aquarius, the constellation, so we call it the Delta Aquarids. Have you heard of that? There's the Taurids that come from Taurus, or the Geminids that come from Gemini, or the Perseid meteor shower that comes from... Sadie got the right answer. Yes. Well, if you hear Perseid meteor shower, you know it has something to do with Perseus, the constellation. And Cepheid variable is a kind of star that was discovered in Cepheus, the constellation of the king that I showed you. Cepheid variables are stars that brighten and dim with a very regular, repetitive pattern that's very predictable. And they are used in astronomy as what's called a standard candle. I know that sounds funny, a candle. A standard candle in astronomy is a star that's useful for measuring distance. And there's a great astronomer who also happened to have been deaf. Her name was Henrietta Swan Leavitt. She was an astronomer that worked at Harvard back in the early 1900s. And she actually was the person who unlocked the code of Cepheid variables. She figured out how we can use their brightening and dimming nature to measure the distance to them. And that work that she did directly led another astronomer that has a more famous name, a guy named Edwin Hubble. He took the data from Henrietta Swan Leavitt and he said, wait a minute, these Cepheid variables that she discovered in Cepheus, I've discovered some of them in the thing that they called the Andromeda Nebula back in the 1900s, early 1900s. So Edwin Hubble used the data about Cepheid variables, the standard candle, the fact that we can measure the distance to them based on their brightness, and he used that to clock the distance to Andromeda's galaxy. And nobody believed it at first because his measurements showed that that was not a nebula inside of our own galaxy, but an entire galaxy of its own, separate from ours and bigger than ours. So you might be surprised to find out that it's been less than 100 years that humans have known that there were other galaxies. During the time of Edwin Hubble, people believed that that Andromeda galaxy was just a nebula inside of our galaxy, and they thought that the Milky Way was actually the whole universe. So that's one of those big universe expanding moments in history when Edwin Hubble, thanks to the work of Henrietta Swan Leavitt, was able to figure out the distance to Andromeda's galaxy. We realized that the universe was not the Milky Way, but many of Milky Way-like galaxies. So that's why the Hubble Space Telescope is named after Edwin Hubble. And it was only less than 100 years ago that these discoveries were made. So we haven't known that the universe is as big as it is for very long. Just imagine Galileo and his telescope showing people that there were more stars than what we could see with our eyes. That was 1609. So you're going from 1609 to the 1920s before humans actually realized that we're really tiny in the whole universe. So does anybody have any more questions? It's awfully quiet.
I don't see any on YouTube, so.
Okay. Well, I mean, I do. At this point, I expected to have a lot more questions, so to use up some of our time. But if there's other topics that you guys would like me to answer, I could talk about anything going on in the sky, even stuff going on in the news. If you have a question, please feel free. And if you are more curious about the reason why we're meeting online and COVID-19, I can certainly answer questions about that as well. But I figured you probably have been hearing so much about that, you might want to use this time as a relief, as a break away from that kind of news. So, well, I'll mention a little bit of a funny thing. Let me go back to sharing the screen. Any of you kids fans of the book Jurassic Park? No? Does anybody know the name of the author of Jurassic Park, the book? I know Leila knows, but before Jurassic Park, the book came out, the author of Jurassic Park, his name is Michael Crichton. He wrote a book called The Andromeda Strain. And that book was about a virus coming to Earth from Andromeda and causing all kinds of bad things to happen here. And that book actually came out just in time for when humans were going to land on the moon. So when the astronauts went to the moon, there was this concern that they might come back with some kind of weird virus, a disease of some sort. And it was partly because of the popularity of the Andromeda strain. So when the astronauts came back, sorry, I'm hearing a lot of echo, so somebody might need to turn down their volume. But when the astronauts came back from the Apollo missions, they had to stay in quarantine for a while inside of an Airstream trailer. See if I can find you a picture of that. I wasn't planning on talking about it, but it's a pretty funny story because this was actually, quarantine was part of what happened to the Apollo astronauts when they returned. And here's a bunch of pictures I'm about to put up on the screen for you guys so you can see some of the pictures from that quarantine mobile trailer. There's President Nixon, who was president in 1969 when the astronauts went to the moon, and you could see the 3 astronauts sitting inside of a modified Airstream trailer. They couldn't get out for about a week as they had to wait to make sure that they did not have some strange virus from the moon. So guess what? We're all like the astronauts. We're all in quarantine. We're all getting stuck in our houses, and we can use that to connect to the Apollo astronauts. And part of the reason why there was so much fear that they could bring back a virus from the moon was because of the popularity of a book called The Andromeda Strain. So it's all connected, kids. All these things you hear about. So that's why astronomy is such a fun subject, because it connects to popular culture. It connects to accomplishments like the moon landings and people's perceptions of disease and the fear of foreign viruses coming to us from unknown regions of outer space. And it's not totally crazy to think that there could be something out there that could be dangerous to human health. I know that NASA has a plan in the not too distant future to try to bring a sample from Mars back to the Earth. This would be called a sample return mission. We're actually doing one of those right now on an asteroid called Bennu with a spacecraft called OSIRIS-REx. OSIRIS-REx is going to scoop up some of the dirt from that asteroid, package it up into a little capsule, and then launch that capsule back to the Earth so we can study. Because of the fact that soon we're going to be able to do something like that with Mars, and because of the possibility that Mars could have sustained life at some point in the past, they don't want the samples from Mars to go straight to the Earth. Can you imagine why? Just like the Andromeda strain. What if some ancient Martian virus gets us? Well, I know it sounds crazy and maybe extremely unlikely, but to prevent any chance of that happening, NASA's plans for bringing samples from Mars on the first sample returns would be for those samples to be picked up by the International Space Station that we could see in the sky tonight at 8:30. So at least only 6 humans will be at risk then. So just imagine, I think there have already been sci-fi movies based on this concept, that those astronauts open a canister from space and they find something crawling inside that they didn't think would be alive. Will it be better if it happened on the space station where there's 6 people than if it happened on Earth where there's almost 8 billion people? So just imagine that we are coming close to having science missions, you know, that resemble the plots of science fiction movies. Hopefully the aliens will be nicer than they are in the movies. Did I lose everybody?
Not me.
All right. We got Taylor still on there. All right. I just want to know who's still following along. Please give me some questions, kids.
Questions? Okay, let me think.
You can also type them in if you don't want to speak them out loud. We've got the chat window. Sadie asked a good question. Why have they not done another moon landing? Well, a lot of these plans are now being postponed, but NASA is actually planning on going back to the moon. It was supposed to be by 2024, but I also know that because of the shutdown of a lot of things going on because of this disease, I know that two people who worked at one of NASA's testing facilities, that where they were testing engines for the rockets to take us back to the moon, they came down with COVID-19, so they had to shut down testing and production. So just like everything else, like the Olympics, our moon missions might be delayed because of this virus. But NASA is planning a new set of missions called Artemis. If you remember, Apollo was the name of the first moon missions. Artemis is Apollo's sister in ancient Greek and Roman mythology. So Artemis, or Diana, if you were Roman, Artemis is going to be the new moon missions. And to make up for the fact that NASA made a mistake in not having women astronauts back in the 1960s, they want to make sure that this moon mission has a woman as the first person to stand on the moon this time. So in 2024, or maybe a year or two later, NASA hopes to have a woman standing on the moon as part of the Artemis mission. But to answer why haven't we done one since the 1970s, is mostly because the moon missions were done as not necessarily a scientific endeavor as much as they were a national pride project that was partly to show off our prowess at the time when we were in the Cold War with the Soviet Union. So the Soviet Union, the Russians, as some people call them, although it incorporated other countries too, like Ukraine and Belarus and Azerbaijan, these were all part of the Soviet Union back before you kids were born. The Soviet Union and the United States were engaged in a Cold War since World War II to kind of prove who was in charge of all the countries of the world. And the United States wanted to show our abilities after the Soviets were the first to put a satellite in space, and they were the first to put a man in space, Yuri Gagarin. So the United States did not want to be left behind in the space race. So we decided to put a lot of money, a lot of funding into landing people on the moon, mostly as a demonstration of our technical prowess. And it was a lot of money, but it was essentially no more than 4% of the national budget. So think about the fact that during the moon landings, 96% of our national budget was paying for other stuff, and only 4% was paying for putting people on the moon. But that's still a lot of money, 4% of the national budget. For comparison, today, NASA only gets 1/2 of 1% of the money that they used to get during the Apollo era. So basically an eighth. NASA gets 1/8 as much money of the national budget as they used to get during the 1960s. So now you can probably see why we haven't been to the moon in a while. It cost a lot of money, and after we demonstrated people in the United States didn't really see the reason why we should be continuing to spend so much money, because those moon missions were very short in duration, and all they did was pick up hundreds of pounds of rocks and bring them back to the Earth. But after you got 700 pounds of moon rock, it was hard to justify to continue going back to the moon in such an expensive fashion. But what I can say that's different about NASA's approach now is that NASA is not planning on doing this as a one-shot deal where we say, "Whoa, we got to the moon," and then we go back home and nothing changes. This approach to going to the moon that NASA is trying to do now is a more permanent basis, meaning we're going to build stuff on the moon that's going to stay there, and people are going to go back to the moon, back and forth. The plan is also to build a new space station called Gateway that will orbit around the moon and can go back from the moon to the Earth, kind of like a shuttle bus going between the airport and the parking lot, going from the moon to the Earth. So it would actually be relatively easy to send astronauts to the moon and return because of a bus going back and forth all the time. And imagine that by the time you kids are old enough to become astronauts yourselves, there might be jobs on the moon where you stay on the moon for months at a time, doing some scientific research, and then you go back to Earth and another astronaut takes your place. And you can imagine us having a moon station or a moon base that's permanently occupied, just like we've had the International Space Station that's been permanently occupied for 20 years now. So all of these are parts of NASA's plan. The first time we went to the moon was just a one-shot deal. Now, when we go to the moon, it's going to be part of a permanent program. So I hope that encourages you, because if you ever wanted to go to the moon, it's not crazy to say that maybe by the time I'm an old man, that'll be like going to Disney World. And I'll be able to say, I'm going to the moon for my vacation because my hips and my knees are hurting and the gravity there is less, so I'll be more comfortable. So I hear somebody typing. I'm hoping that's a question. Anybody out there got a question? Leila, anything from YouTube?
Nope, there is one. Can you remind us how long it takes to get to the moon?
Based on the way that the astronauts went there, they didn't fly in a straight line. They would take off from the Earth, orbit the Earth a few times, and then they would get slingshotted out towards the moon. So altogether, it took about 2.5 days to get to the moon. And once they got to the moon, it took a few hours to go from orbiting the moon to landing on the moon. And when the Apollo astronauts went to the moon, they stayed there in the first time, Apollo 11, for less than 24 hours. So they walked around on the moon, they set up a bunch of science experiments, and then they got back in the spaceship and made their plans to launch from the moon back to docking with Michael Collins in the Columbia module, and then those two spacecraft together flew back to the Earth. So altogether, they spent about 5 days in space, but less than a day of that was on the moon. So if you're going to go through all that trouble of sending somebody to the moon, you might want to have them stay there for more than a couple of hours or even a couple of days. So that is why the new plan that NASA has is more gradual, but it's also more long lasting. It's more of a permanent visit as opposed to just a temporary quick trip. But imagine being on the moon, you'd have 1/6 the weight that you have on Earth. So just imagine if you want to work out, you could like bench press like 500 pounds and pretend you're really strong, but it wouldn't really be 500 pounds. It would just look like you could show off, pretend you're super strong. It actually weighed less than 100 pounds on the moon.
What about space travel? I feel like I watch a lot of movies about people traveling in space, and is that realistic? The way a spaceship travels? Because I feel like there would be no sound, right? So when you hear jets and stuff, that shouldn't exist. And then also, once you get up to like they show them taking off and going really fast, like warp speed and stuff like are those things possible even?
Well, I wish we had warp drive or hyperdrive or all the other crazy faster than light technologies that exist in science fiction. The fact that humans imagine it in science fiction makes me think that one day in the future, it will be science fact. But right now, everything that we have is super slow compared to the spaceships in movies. And fighters, none of that would happen in real life because there's no sound in space if there's no air to carry that sound. But imagine watching an X-Wing TIE fighter battle with the mute on. Wouldn't be that exciting. And you wouldn't have John Williams soundtrack blasting in the background either. There's no orchestra in space playing French horns like we see in the movies. However, I do see a question here from Sadie about, do they have a strong enough telescope to see any of the pieces left behind by the previous missions? Well, you actually don't even need a telescope to see that. There are amateur satellite trackers, people who are very dedicated observers of the sky, who know and can find pieces of rockets going back to the Apollo era. It's crazy, but space junk is the general term for this concept of the fact that we kind of made a mess of things up there in the past. Now, people who make satellites and rockets know that it's their responsibility to make sure that whatever they put in space can be taken out in a deliberate and careful fashion. But in the early days of space exploration, they did not make those provisions. So a lot of rocket stages and disabled satellites that no longer work are still orbiting the Earth right now. And that is a big problem for future missions, because if we lose track of where these things are, they can be a serious problem for people, in the future. Each piece of space junk is orbiting the Earth at something like 17,500 miles an hour. So imagine through you lost track of, and you're going up there to make a new satellite, and that little screw hits your satellite at 17,500 miles an hour. Well, that's going to be the end of your space mission. And it's crazy, but well, here, let me, I was trying to think of a way to visualize this for you guys. There was actually a couple of months ago, two satellites nearly collided over the city of Pittsburgh, Pennsylvania. They missed each other by 40 feet. And if they had hit each other, it would have been quite a big explosion. It might have looked like something like this. I'm going to try to share this with you guys, see if this works. I'm going to try to play a video, and let me know if the video comes out clearly. But I'm going to show you what it looks like when we intentionally let a satellite burn up in the atmosphere. This was intentional. So this was controlled, and we knew that it wasn't going to hurt anybody. But check that out. Can you guys see that video?
Yeah.
That is a spacecraft called the Jules Verne, which was a supply ship that was intentionally flown to the space station to resupply them. And here's the dirty secret. They filled it up with all of their junk and waste and poop. And then they let it go back towards the Earth, and it got shredded by our atmosphere. So everything inside of that was completely incinerated by flying through the atmosphere at 17,500 miles an hour. Imagine the rug burn. Imagine the friction of all the air rubbing up against that. So this is when it happens intentionally. But imagine what would happen if one of these things crashed into each other unexpectedly. So what do you think of that? I see a question that came in. And also, I wanted to, before I get to that question, let me, hold on. I think, and I'm not sure exactly what you guys are seeing now, but I'm trying to switch to another display here. Can you guys see this picture that says orbital debris?
No.
Okay, oh yeah, hold on, I must have messed something up. Hold on a second, I'll fix it. Here, can you see it now?
Yes. Yes.
Okay. So to answer your question about the stuff that's up there, this picture is not to scale. So I want to make sure that you don't freak out thinking that the Earth actually looks like that from outer space. No, all of these satellites are too small to see at the distance that I'm showing you, but this is a real visualization made by the European Space Agency of how much stuff is out there. So you could say that we kind of have a little bit to be ashamed about when it comes to littering outer space. It's not quite as bad as it is in that movie WALL-E, but it could easily become to a point where it might be hard to launch new satellites because old satellites are constantly crashing into them and causing chaotic storms of junk in space that we can't deal with. So luckily, the space community has agreed that this can't be the case anymore. And all future satellites have to have a method for deorbiting them safely so that they won't become a dangerous piece of junk floating up there for future astronauts to have to worry about. It's serious. I can actually show you what would happen if a spaceship, hold on, I'm gonna stop that. I don't know if you guys can see it there, but I have a picture of what happens when they tried in a laboratory to fire a piece of metal at a piece of aluminum at the speed that things orbit, so you could see what would happen to the ISS if it got hit by orbiting debris. It would not be pretty. Let me show you. This is a photograph. I'm going to give this to you guys in a second. I'm going to put it up on the screen. This is from a NASA experiment where they fired a projectile at 17,500 miles an hour at a piece of aluminum to see what could happen to the International Space Station if it got hit. And what does this picture look like to you?
Not pretty. A
Well,
hole in the...
that's like a bullet hole, right?
Uh-huh.
That actually was on the International Space Station. And you how, well, I'm going to show you that how that experiment was done. Hold on. I think you guys are seeing other pictures than I intended, but yeah, that, oh, anyway, I'm sorry that I don't have that other picture ready, but that is the danger of being in space. You've got all this stuff, everything is moving really fast. So even a micrometeorite, even a natural rock from the orbiting dust in our solar system can do this to you. And let's see. Now, I want to ask, somebody asked a question about what do they hope to learn about these new missions on the moon? Well, and I mean on the surface of the moon, was it one of Elon Musk's 5G satellites? So that, okay, I'll address those as separate questions, but the surface of the moon has a lot to teach us, not just about the moon itself, but also, as what NASA would say, is a preparation for going to Mars. So if we now go to the moon in a permanent fashion and we learn how to build a base there, we learn how to keep astronauts there for a long period of time, all of that is going to make it easier to do the same thing on Mars. So in one way, you could say that the moon is going to be our Mars rehearsal, our Mars dress rehearsal. We'll get to try out all the hardware. We'll get to try out all the spacesuits. NASA has been designing new spacesuits already. They're already designed for these missions. And we'll be able to test them out on the moon, which is really close. Remember, it only takes 2.5 days to get from Earth to the moon. So if something goes wrong and we need to get those astronauts back, we can probably get them back within 2.5 days. The problem with going to Mars is you have to have a commitment, because flying to Mars takes at least 9 months. And when you get there, if you break a leg, they're not going to send an ambulance to get you. So everything about going to Mars is very dangerous and very risky, putting you in a position where you have no help if something goes wrong. So it would be much better to practice for all that on the moon, where we are a lot closer to home in case something unexpected happens. Then we'll learn how to deal with it so that when we do send astronauts to Mars, it won't be such a scary experience, and at least we'll have the background of the experience of colonizing the surface of the moon as that. Now, somebody asked about Elon Musk's satellites. Well, you know, I have mixed feelings about Elon Musk as an industrialist. I think a lot of the things that he's doing with SpaceX are pretty awesome, but there's something that he's done that is not so awesome, in my opinion, and that is what is called Starlink. And just to make it clear, I'm going to put up another picture here. Let me explain. First, let me put it from the perspective of SpaceX. Starlink is a new series of satellites that are designed to give the world internet. So imagine like Wi-Fi routers orbiting the Earth, so that no matter where you live, no matter how remote your country or how poor your country is, you could at least log on to the internet from anywhere. And they say that they would try to make the service as cheap or even free eventually. That sounds awesome. I think most people would say that that would be a good thing for humanity. And here's the Starlink satellites being deployed. In fact, I have a little video here of them actually coming out of the rocket. I don't know if you guys can see that. I hope the internet is allowing you to see this smoothly. But they deployed at one launch 6 satellites at the same time. Then they said that this was just part of an array that they hoped would include up to 12,000 satellites. Can anybody see a potential problem with this? Well, the day that they launched let me show you what a satellite looks like when there's only one going in front of a picture being taken by a telescope. So here is a Hubble Space Telescope picture where by luck or by accident, a satellite happened to go by. And what did it do? It created this bright stripe of all that reflected light, causing like a long exposure in the satellite that kind of ruined the picture. But that's okay, because if there's only one satellite, you could just take another picture a few minutes later and that'll be gone. But there was an astronomer down in Arizona at the Lowell Observatory in Flagstaff that saw the Starlink satellites coming by, and she decided to turn on the camera in her telescope and look at what she photographed.
Yeah.
There was more satellites than stars visible in this picture. And it made it almost impossible to do any kind of astronomy. So there's a couple of reasons why I'm concerned about the Starlink project. I think it's a great idea to bring reliable, cheap, or free internet to the whole world. But what does that mean we'll lose? If these satellites are deployed, they've only deployed about 120 of them so far. What if they deploy 12,000? What if there's more satellites visible to your eye than stars? Do you want that to be the case in the sky?
No!
Well, that would be like one company got to decide to cancel the sky for all of us. And I don't know if anybody or any company or even a whole country should have that power to change the way the sky looks. We've been talking about constellations that go back 6,000 years. Can you imagine in a dystopian future, humans saying, yeah, do you see those lights that aren't moving? Yeah, I know they're hard to see. You're gonna have to squint. But those lights that aren't moving are the stars. Yeah, our ancestors used to see them and make pictures with them, but we can't really see them anymore because now the sky looks like a swarm of fireflies with satellites going around. Maybe that's the future, but that's not the future I want to see. I think we can do both. I think we can provide services like the internet to everyone in the world without wrecking the view that we get from the earth of the sky. So I think SpaceX realized that there was a lot of public backlash, and they said that they're trying really hard to make sure that their satellites are not shiny and reflective in the future, because these satellites don't have lights built in. All that light that you see in the picture is reflected sunlight hitting the shiny metal parts of the satellites. So that was caused by, well, you guys saw that. Sunlight reflecting off of these shiny satellites. So that's the view from space, and that's the view from the observatory in Arizona. Oh, it looks like we're coming up on the end of our time together. So this is probably your last chance to ask any questions. And I'm going to say this is not as much fun as it is having you guys in person in our planetarium or in our classroom. So I really miss you guys. But I think if you read the news and know what's going on with this COVID-19, all of this that we're doing is definitely worth it. It is, by not meeting with each other, we could be saving the lives of people that we don't even know. So just to kind of put up something to remind you of why we're going through all this trouble. Here's a picture from the New York Times. They had a recent article about why it's important to keep this social distancing. You see the top picture has a person hanging out with their two friends, and they give their friends the virus, and then their friends end up giving it to hundreds of people that they meet along the way. So if you can avoid just one of those encounters, you can avoid giving lots of people an infection. And what if one of the people in this diagram was someone who ends up having, serious problems from this disease? You could be saving their life just by staying home. So I know you kids like to do things and you like to imagine that your actions can help save the world. It's hard to face the fact that now it's inaction that might save the world. But that's what we need in this particular time of plague. We need you all to stay home and not go out and hang out with friends and not socialize. The more lives we will save. So this little inconvenience, as much as I could complain about teaching you guys online, is a much smaller inconvenience than having to see a loved one suffer with a horrible illness. So look at it that way. I can't wait till I can meet you guys again in person, but all of this inconvenience is well worth it when it comes to protecting our community. So maybe we just, does anybody have any last questions? What's that?
Thank you so much, Bobby. You did an awesome job. I feel like we learned a lot about the night sky. I wrote up some notes, so I'll send those out as well. But we just wanted to close out for our YouTube viewers. Thank you so much for joining us, and look for additional classes online again tomorrow at 10 and 1. And if you look on our virtual learning page at Fairbanks fairbanksmuseum.org. Check that out and look for additional classes. Thanks.
All right, thank you, Leila, and I miss all of you. Be well, wash your hands, stay safe, and remember, you can't get sick from looking at the stars. So do as much stargazing as you possibly can on every clear night. I hope these clouds clear up. But remember, and also make sure to check out the International Space Station at 8:30 tonight. Look towards the north. While you're looking at the Big Dipper, you might see some people fly by. So otherwise, I wish you all well and have a great evening.
Thanks, Bobby.
Bye, Bobby.
My pleasure, guys. See ya.
Bye.